Hi, Polydoorway here. Today we're gonna continue our mini series of the wood barrel. Today it's part 2 of this mini series. So let's see what we're gonna do today. First, we're gonna find the final shape of our barrel. Then we're gonna set up the curves for the armature rings. And finally, we're gonna create the armature geometry. So let's start modeling. So in the previous video of this series, we left off with this geometry, the base of the barrel. So we're gonna start by creating the final shape. And before we start, a couple of things first. The line node will be important because it will give the length that control the height of the barrel. But the second property that controls the resolution of the line will give us some cuts for the plank. This will be important to give the final shape of the barrel. So let's add some points. Let's make it 6. And before our new node, let's center this geometry because the bend node offset it a little bit. So let's grab a match size. We only need to affect the justify X property and the justify Z property. So in the justify Y property, let's change it to none. And now our geometry is back to the center. Next, to ensure that we always have a cut right in the middle of our barrel, we're gonna use a clip node. And the orange of this clip will be in the center of our barrel. So here in the orange property, we're gonna set up the Y position. So let's use the centroid function, centroid of the first input, 0, Z underscore Y. Because we're gonna center it in the Y-axis. We also need to change the keep property to all primitives. And now we have a cut right in the middle of our geometry. Nice. Next, to give the shape of the barrel, we are going to use a ramp attribute to change the position of the points so we can give a proper shape. So let's grab the wrangle node, attribute wrangle. Let's name it barrel shape. And we're gonna color it orange because it will be an important node. So here in the expression, we're gonna need the size of our barrel. So we're gonna use the bbox function. So let's declare a variable, vector bby. And to get the bbox in vex, we're gonna use get bbox. We have some functions, but we're gonna use get bbox size of the first input. And now we're gonna create the ramp property. float ramp equal ch ramp. Let's give it a name, ramp underscore shape, comma. And to give the proper ramp value, we're gonna use at p.y, and we're gonna divide by our bbox size. bby dot y. Click in this little icon to create the ramp. And we did this division to grab the y position of each point and divided by the total size. So the point in the bottom will have 0 value because its y position is 0, and 0 divided by anything is 0. And in the top, this point will have the value of 1 because they have the same value of the bbox size. So our values will change between 0 and 1. If we change this variable to a property at ramp, we can see the ramp values here, and it's changing between 0 and 1, as we can see here. This will match perfectly with the ramp. So to finish here, we're gonna change the x position and the z position with this ramp value at p dot x times equal 1 plus ramp. And we're gonna copy this expression to change the z value to at p dot z times equal 1 plus ramp. Oops. Let's change this value to a variable. So float ramp. Now this ramp property is changing the shape of our geometry. Let's give a proper ramp curve. Let's give a point right in the middle. So the position can be 0.5. And this last point, we can change it back to 0. Now we have a shape that is almost there. So to finalize our shape, we only need to change these points to be in a different interpolation type. So let's select these points and change the interpolation property to B-spline. Now we have a better shape for our back. Now, to set up the armature rings, we're gonna need a line that matches the size of our barrel. So let's create a line. Let's create a spare input here in the gear and grab our barrel geometry. Here in the length, we're gonna use the bbox expression again. Bbox 0, oops, -1, the white size. This -1 reference to the pair input. Next, we're gonna use the carve node to give a safe area to place our armature rings. We're gonna use the first U and the second U. Let's turn on the second U. And here, let's change these values. Nice. Then we can use the resample node to give more points to this line that will serve as placeholders for our rings. Let's grab the resample node. And here, instead of use the maximum segment length, we're gonna use the maximum segment to control how many armatures the barrel will have. This node will be important too, so let's color it orange, because this property will control how many rings we're gonna place in the barrel. Next, we're gonna need to know the distance between this line and the edge of the barrel. So we're going to use the ray node. So let's grab the ray node. We need to transform the line to match the edge of the barrel. So we're gonna use the transform. Let's create a spare input. Here in the gear, add spare input. Let's grab our barrel geometry. And here in the Z translate, we're gonna type dbox -1 to reference the spare input, the Z min. Now we translate our line to match the edge of the barrel. So this will be in the first connection of the ray. The second connection will be our barrel. So to give a proper geometry for the ray, we're gonna use the fuse node to ensure that our point is all connected. Next, we're gonna turn the geometry into a volume. So we're gonna use the VDP node, VDP from polygons, connect to the first input. Let's change the voxel size to have a proper volume. Nice. Now we need to convert it back to a geometry. Let's grab the convert VDB. And change the convert to property to polygons. Nice. Let's connect it to the second input of the ray. And now let's set up the ray node. We're gonna change the direction from to give a vector that is reference to the Z direction. So let's change it to vector. Delete the values of the ray direction property. So right click, delete channels. And here in the Z direction, we're gonna set it to 1. Now our line is matching the edge of the barrel. It's a bit hard to see, but let's grab a new node. So we can see it better. Very nice. Now, we need to know the distance between the original points of the line to this new line. So let's grab a rainbow node. Let's connect it our original line in the first input. This transformed line will be in the second input of the attribute rainbow. Now let's grab the position of each point of the transformed line. So vector pos equals point of the second input E at pit num, and we need to find the distance between the original point and the transformed point. So we're gonna set this distance to the p-scale attribute. So at p-scale equals distance between the position of the original point and the position of the transformed point. Now, we have the p-scale value. This p-scale will serve as the scale of a circle shape. So let's create this shape. Let's grab the circle node. Let's change its orientation to the ZX plane. And we can give the same divisions of the number of planks that forms our wood barrel. Let's go back here in this barrel length node. Let's copy the number of planks, right click, copy parameter. And here in our circle node, we're gonna paste this reference to the divisions. Right click, paste relative reference. Nice. Now we're gonna copy this circle shape for each point we have in the line. Let's grab the copy to point node, connect the circle in the first input and our point in the second input. Real nice. Now we can control how many rings our barrel will have. We just need to change the segments property of the resample. Let's name our nodes, number of rings, and let's name this attribute rainbow to set scale attribute. Let's color it light yellow because it's set in attribute and it's kind of important. Let's grab a new node and let's name it ring curve. And let's color it with a blue color because it's a curve. Let's check if everything is working properly. The points of the circle needs to match the points of the barrel. It is matching, but they are not aligned. Maybe we need to transform the circle and rotate 180 degrees. Yes. Let's see with other number of planks if it's still working. Yes, it's working. Nice. Now let's move on and create the geometry of the rings. First of all, we need to give some normals. So let's grab a polyframe, connect our ring curves. Let's change the entity to points, style first edge, and the normal we will attribute to tangent name. So let's turn off normal name, and here let's change to N. Now we have our normals. Next, we need to create a profile for our rings. So let's grab a grid. Let's change the orientation to XY plane. And let's change the resolution. We don't need any divisions, just a regular plane. And we need to change the size. We need a small size. So let's see, 0.01 maybe, and 0.02. Let's see. I think it's too small. Let's give another size, 0.2 and 0.3. Let's see if this configuration works. Let's grab the sweep node, connect the first input with the ring curves and the profile in the second input. Nice. Let's change the size here. 0.03. 4. Yes, it's better. Maybe we can do a little offset of the rings. So here in the set scale attribute, let's create a property, float offset, is equals to the channel. Let's name it offset. And let's add this offset to the distance plus offset. This offset is the half of the size, so we can maybe we can link it to turn it procedurally. So let's grab this reference of parameter, and here let's paste this reference and multiply by 0.5. Yes, here it's working too, here too. Let's see the two geometries combined with the merge node. Everything is working fine. Maybe this offset is too much. Let's grab only a quarter of it. Yes. Yes. Let's change some parameters to see if it's still working. Nice. Number of planks is working. Let's see the length. It's working too. Nice. Now to finish this video, let's set the UVs for the rings. So here in the sweep node, inside the UVs and attributes tab, let's turn on compute UVs. And to have the UVs with the proper size of the rings, let's turn off normalize computed use. And here in the UV scenes, let's turn off the snap U to nearest tile boundary and snap V to the nearest tile boundary too. Let's grab a null. And that's it, guys, for today. In the next video, we're gonna see how to create the bolt for each ring, and we're gonna create the interface of the HGA so we can expose some parameters to control some elements of our barrel. Thank you and have a nice day, and I see you next time.